Lesson 5.4 is on solving compound inequalities. In this lesson, you will learn to solve compound inequalities containing the word and graph the solution set. And you will learn to solve compound inequalities containing the word or and graph their solution set. So, the compound inequality, intersection, and union are the vocabulary words that you will need for this section. So, example 1, if you want to be able to graph an intersection. So, in a compound inequality, the idea is still to get the variable by itself. So here, if I'm looking at what's being done to the variable, 2 is being added to it. So to get rid of that plus 2, I want to subtract 2 from it. Now, what I do to this part of it, I have 3 parts, 1, 2, and 3. Normally in an equation you have 2 parts, but here in a compound inequality it's like we have 3 parts. So whatever I do to one part, I have to do to all 3 parts in order to keep this inequality true. So I do 7 minus 2 and I get 5. Z plus 2 minus 2 is just Z, and 11 minus 2 is 9. And I keep the inequalities the same, unless I'm multiplying or dividing by a negative. So I get 5 is less than Z, which is less than or equal to 9. So basically, if you want to think about it, Z is between 5 and 9. So the second part of this is to graph the solution set. So what I'm going to do is I'm going to make a number line that includes all of the numbers that I have. So from 5 up to 9, we have to have at least those. So I'm going to start at 3 and then go up from there. Okay. So if you guys remember when we were graphing inequalities earlier this year, if it doesn't have that or equal to, it gets an open circle because it's not including that point. If it has the or equal to, it gets the point. So looking at this, I'm looking at 5. At 5, I'm going to put an open circle. Okay? And then at 9, I'm putting a closed circle. Okay? And I want the z values to be in between those two things. So z is going to be greater than 5, but it's also going to be less than 9. So my arrow is going to be in this area. Here, like this is going to be my solution set. Poorly drawn, but you get the idea. Okay. Example 2, writing and graphing a compound inequality. A ski resort has several types of hotel rooms and several types of cabins. The hotel room costs at most $89 per night, and the cabins cost at least $109 per night. Write and graph a compound inequality that describes the amount that a guest would pay per night at the resort. Okay, so there's 2 options that you can have. You can have a cabin, or you can have a hotel. So if we're looking at the price for a cabin, it says the cabins cost at least $109 per night. So that means the price, we're going to call X the price, it's going to be more than or equal to 109, right? The least it could possibly be is 109, so it's going to be more than that or equal to it. Okay, so then for a hotel, the price is at most $89 per night. So that means the price is going to be less than or equal to $89. Okay, because the most it could possibly be. So now this is an or situation, right? This is not including, you're either going to be spending more than 109 or less than 89. There's no option of how you can get in between there. So when we go to graph this, this is our system, our compound inequality. It's this or this. So when I graph an or statement, let's say I have 70, 80, 90, 100, and 110. So 109 is about here. I'm going to do a filled-in circle because of this, and I want values that are greater than that. So my arrow is going to be going that way. And then for this one, 89, it's about here. Again, it's a filled in circle because of that or equal to. And I want values that are less than it. So it's going to be going that way. So generally, a lot of the or statements, you have a gap in the middle. So it's either going to be going this way or that way. So let's solve this last one. If I want to solve, if you're given something like this, you're going to solve each inequality on its own first. So to solve this one here, you want to get the k by itself. So the first thing I'm going to do is add 7 to both sides. When I do that, I get 4k equals 32. To get k by itself, I'm going to divide both sides by 4. So I get k is less than or equal to 8. And then I want to solve this one. So for this one, I'm going to subtract 12. So I get negative 9k is greater than or equal to 18. To get k by itself, I'm going to divide both sides by 9, negative 9. Remember, dividing by a negative switches the direction of the inverse, or the inverse, the inequality. So I get k is less than or equal to negative 2. So now I just want to graph those two things. So k is less than negative 2, or k is less than 8. So if I were to look at these, if I were to graph each one, so let's say this is negative 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, poorly drawn, my bad. So k less than 8 or equal to 8. That would be a point here, and it would be going that way. And if I have k is less than negative 2, that would be here and going that way. Okay, so for this is kind of redundant because this 8, it keeps going all the way this way. So it kind of overpowers this negative 2. So when it says or, that means it has to be true for one of them. So if I picked a number in here, let's say I picked this 0, or 0, does 0 meet one of these requirements? Is 0 less than or equal to 8? Yes. Is 0 less than or equal to negative 2? No. But because this is an or statement, I can say that it's true because it has to meet one of them. Or means it has to meet one or the other. It doesn't have to meet both. If it said and, then it has to meet both. But because it says or, it only has to meet one. So that means my final solution is going to be anything less than 8. That less than or equal to 8 overpowers this thing. So my final answer is just k is less than or equal to 8. And when I graph it, I'm just going to do from 8 and then go the other way. I don't have to worry about that negative 2 because it's implied, because negative 2 is less than negative 8. So if something is less than 8, it's obviously going to also be less than negative. Wait. If something is less than negative 2, it's obviously less than 8 also. Okay, so we don't have to include that. And that is 5.4.